is to record. Yeah, I think we did this problem and you would find it, well, we already started it, but I have to complete the total concept. So if you find it, we already did it. Trust me, there are still a couple of things that are left in this problem. So I actually will finish the problem today by formulating it again. This time around, you have to finish the problem completely. So again, we have a rack and pinion. I cannot start anything else today. No, we will finish. Then we will start. So just bear with me. We are going in the right pace. So I have, what was the R1 is equal to 150. Yeah, for some reason, I think the R1 is not appearing on the whiteboard. R2 is 100. VA is, let me use a color. This is your rack. And this is the pinion. The other one is pinion. The question says that this is my nice and beautiful center. And this center of the disk is going at 1.2 meters per second. No need to exaggerate. Again, this problem will be done by you. And I have 3 meters per second scale. How many agree? Okay. This chunk is 3 meter per second square. And this is 1.2 meter per second. Okay, and now I have a ground. And the ground is how many agree? It is point C. This is point D. This is point, what was this point? Anyone knows? B, right? This is my point A. There is a no slip condition. Okay, I think light is less. Boom. No slip condition. So we have students who are saying, what is different in today's problem? Find alpha and A of all the points B, C, D. And let me give you the coordinate system. So all of us today are on the same page. Trust me, this is not an easy problem. You think this is easy? No, it's not. Okay. This is my capital X. Again, there is no need to even write a small x here, but it's okay since we have been solving this. Okay. Hasong, Muhammad, Hashir, Faraz, Oze. Everything is fine, right? You can see the problem. Okay, we have Peggy Chan who has joined the class. And the colors have vanished. Oh, come on. Okay. Do it. Start the problem. Give me the initial 2 steps, at least. If you want, I can write the formulas for you. This problem shows up in exam, right? Immediately you start writing the acceleration formula, that's fine. But with practice, you already know acceleration has omega, acceleration formula has omega square r in it. Acceleration formula has omega square r in it. I know it. Do I know omega in this problem? No, that's fine. That's from last week. But right now, today in this class, right now, I don't know. So you have to first crack the omega. By the way, I will be using the omega from last class. Very good. You are right. But you have to do it. Oh, I think R1 and R2, I have to tell you from the last problem, but I should, yeah, but I should, I think for students who are attending the class first time at least, this was R1 and this was R2. Okay. Okay, I think I will start the problem. So from our last class, we got omega as minus 8k, right? Because it was clockwise. If this is not clear to any student, you will tell me and I will come to your desk and we will quickly go over this. Last time we did. Very good. Now I have to crack alpha. So the strategy is that this is given to me. So AA equal to, I don't know. Let's pick which point? C, let's say AC plus tangential acceleration from my previous physics classes. The big formula I have told you, A with respect to C. Then normal acceleration from my physics classes. The big formula I have told you, omega AC bracket, omega AC position vector A with respect to C. Then Coriolis acceleration, whose physical interpretation is still to be done in this class. It's a little hard to physically describe Coriolis because of this. Oh, hang on. We don't even need this. Sorry. We don't need Coriolis acceleration. Oh, for sure. Yeah, that's even funny that we are even writing it. Sorry. But just for the sake of completion, again, very funny that we are even writing this small xyz terms. Okay, what is the value of AA, 3 meter per second square. Do I have any y component of acceleration of point A? No, because it's going in a very straight, it's rotating. So the object is accelerating, the center of mass is accelerating only in the I. It's not curvilinear motion, it's just it's going towards the AC. We have already talked about it in last class. We had quite a discussion that in no slip condition, AC only exhibits a normal acceleration component. So only J. If you write I here, you will get confused in an exam. Alpha, okay, I have no idea. So I have this intuitive feeling that if the object is accelerating towards right, feels to me that the object will have clockwise alpha. I don't know. If you disagree with me, you can write a different. A with respect to C. I don't know. You can tell me. Anyone who can help us? A with respect to C is A with respect to C is in the positive y direction. 150. Thank you. 0.15 meter plus omega AC from my last class when I tackled this. Yes, J. I missed it. J. Thank you. Minus 8K. Again, very easy to make a mistake here. There is a cross, then there is a bracket. You don't put a bracket, everything is wrong. 0.15 J. Boom. Done. Over. Okay. So now all I have to do is just crack this problem. So 3 equal to K cross J is K cross J is minus I plus I plus so this is alpha I K cross J is a negative I, positive I, K cross I is a J, negative J. Sure. 8 heads are 64. 64 into 0.15. 9.6. Okay. I think I made a mistake. There is, or probably not. So, yeah, I did right because, sorry, 3I. Oh, what am I doing? 3I equal to why did I write this here? I don't think I should write.
We didn't add AC.
ACJ, J, K cross J is this one. This is J. Oh yeah, you are right. Minus 9.6 J. Thank you. So I will write minus 9.6 J here. And I will write 0 equal to AC. I am separating them, right? I and J, right?
And also, we didn't write 0.55 to alpha times 0.55.
Yeah, the I part has to be
this one?
0.0.
Yeah, you're right. I think 0.15 should be here, right? I think this is what he meant. This is my equation 1. I think so. Left and right, but we have arrived at. Okay, everyone. So I think I will just remove this because I should have I here. I should have 0J here. So let's remove I and J. So alpha comes out to be 3 divided by 0.5 is 15 twos are 30. 20 radians per second square. Direction, all of you have to tell me. Clockwise, right? My initial assumption was correct. So, you know, it is very beneficial that you write here minus 20K. You don't write it in an exam, it will be hard for you because you will forget. And AC is 9.6. And I assumed my AC as like this, positive J. So nice and beautiful positive J. Yes.
So for getting the answer positive, it means that our assumption is correct.
Positive.
It will be in negative k direction. If the answer comes to negative, our assumption is opposite to real value, so we will change direction.
I will answer this in this way. After the colors are adjusted. Oh, come on. Good. When answer is negative, that means maths tells us that your assumption is wrong, negative.
Wrong, so
Ah.
we need to change the
We have to tell us. And the positive means I agree with you. Okay, now you don't stop here. You make nice and beautiful arrows. I will avoid the yellow color because the colors keep on getting messed up in this classroom projector. So this is the AC. Agreed? Good. Then what about the acceleration here? It is 3. So I will make a nice and big arrow. Okay, this arrow will be big. This arrow should be little small. Okay. Of course, I am not drawing up to scale, but you get my point, right? So this is 3 meter per second. Okay. AD 100% you are doing. Give me AD quickly. Write the bit formula. You write the bit formula and you tell me AD. Please find the AD, our online students. Acceleration at point D. Yeah. Again, this is a solid disk. The inner portion, the outer portion, everything is solid. So let me actually color it. Again, I will color it. Nice and beautiful, solid disk. AD equal to AA, yes, that's a good thing. AD equal to AA plus
for English,
you have already found.
yeah, we already found the part. We said that the velocity AC will be minus 8K.
Right.
So the center will be in A, right? For the velocity. Will be not in between A and C.
What?
Right.
Omega?
For omega, like we find that.
That's fine, but omega is omega for the whole disk. It's a rigid body. So omega at the center will be the same as the omega at the corner. Will be the same as omega at any other place as long as it's one rigid object.
One rigid object.
Same story for alpha.
Yeah, sure. So the vector of the omega can be
Omega and
like this.
alpha. Omega and alpha are the same on one.
Previously you gave us the direction of omega, but you haven't given us the direction of alpha. How do you know that it's minus I?
Yeah, because I made an assumption here.
It's just an assumption.
But the answer came out to be positive, 20, which said your assumption is correct. Maths told me.
So the object is rotating clockwise,
But it's
also accelerating. That's
angular
what
acceleration is also clockwise.
this is the same direction as the angular. So this is just an assumption. But the previous question.
It was an assumption
You
here.
gave us angular velocity in the like this. So we just assume that the question doesn't
Omega?
give us. Yeah.
No, no, omega is from the last class.
Okay.
In my last class,
given. Like in the question, like
No.
as in like the direction.
It will not be given. Omega will not be given you in exam. No,
Direction.
I'll tell you. Hang on. This omega I solved in the last class.
I get it. You didn't understand my point. I'm trying to make the point that the direction is given to us, or we just assume that.
We got hold of the fact that omega actually is clockwise. Because just imagine,
At first, we just guess.
oh yeah,
That's what I was.
no, but for a problem as
I understand.
for a problem as simple as that, it's not even a guess because if this rack, I'm sorry, if this center is rotating like this,
It's moving this.
for sure the omega is clockwise. So in problem as simple as this one, omega is not even a guess. It's very clear. But for a complicated problem, many times it's hard to imagine. So you take a guess and the math tells us whether you are right or not. Anybody who wrote the formula for AD? Can you AD? Yes. Yeah, that's fine. Good. AA equal to AD is also fantastic. You are right. AD. AD. So how did you write? You will not write ADI plus ADJ. You will write ADXI plus ADXA. Anyone here who wants to? I found what it's from. Why? It should be. Not necessarily. No, because normal acceleration is something that is dependent on omega, and tangential acceleration is something that is dependent on alpha. So your AD will not have a 45 degree. I highly doubt it. We will double check. So if your components are coming out to be different, everything is fine. So positive. Okay. So what happened? Okay, hang on, everyone, hang on. We are about to go at sonic speeds, by the way. AD equal to AA plus, okay, again, this big giant formula omega. From my physics, they told me that if you see omega square r, that is normal acceleration. That's what they used to tell me, right? Then they used to tell me that wherever you see this is tangential acceleration, then these two components are going to be a joke in a problem like this. Do not even write them. Come on, like it's not needed. Big zero. Big zero for small xyz, because there is no particles are not going or moving towards each other. Okay. So AD equal to AA. Okay, now there are students who are saying we don't want to use AA, right? There is someone who is using AC. That's fine. But I'm definitely going to use AA because I'm more comfortable in that one. 3I plus omega is the same, minus 8K cross. Yes. Position of D. D with respect to A is minus. What was that? But how much? 150? Good. Minus 0.15 I. Alpha minus something we got. 9.6 K into position of D with respect to A. Alpha is 20. Alpha is 20. 0.15 in the negative. We did get the 20 right? Okay, good. Alpha cross R plus 0 plus 0, it's not even needed. Don't even write them. In fact, oh, come on, it's not even needed here. Nobody writes these terms. Okay. Okay, so AD comes out to be, I don't know, 3I, then 8 8s are 64. 64 into 0.15 was 9.6, right? And K cross I is a J, positive J, K cross J is a negative I. Like this. Okay, K cross I is a J, K cross J is a negative I think so. So, correct? I'm just writing too fast, so there is a possibility of mistake. And then 20 into 15 give me 3. Sure? Positive 3J. Okay. The answer comes out to be 12.6I plus 3J. So your answer was correct actually. So what is the value of ADX? It is 12.6 meter per second square in this direction. And ADY is 3 in this direction. No, you asked me the question. What happened? What happened? What is the question?
I was like, I was doing like A to AD. So I was confused.
You're confused on?
No, I did the other way, like A to AD.
Good. A equal to AD plus?
Yeah.
You can. Good. Okay. Okay. So why are the x component, that is the normal acceleration, and the tangential are coming out to be different? Because of course in general they are different. So you cannot get a 45 degree. So we will go back very quickly. Oh, what happened? What was the value of this one? It was something, I don't know actually.
9.6.
9.6. And now you are getting 12.6 and 3. So I will write a big arrow. Boom. Big arrow. Correct? And then small arrow for 3. Right? I think it's clear. 3 meter per second square. I think you get my point. Then what is the resultant fellow? The resultant fellow is in the red arrow. That is boom. Game over. So you can do the square of this, square of that, take an under root, and you can give me the magnitude of this little fellow. Oh. Anyways, whatever it is, no, it's not even needed for me. I'm just telling you can do it for yourself. Boom, done. Okay. So this is 1 point. Okay. Should I proceed or not? Should I? What about our students? Ege, Chan, Muhammad Hashir, Faraz, Uze. Should I proceed? Okay, Hashir. Oh, charger. Otherwise, we are finishing soon today. Should I proceed? Okay, give me the AB quickly. 654321. Give me the AB. Quick AB. Oh, right. No, you haven't. Hang on. AB equal to AC, correct? Plus omega B. Very nice. Plus good. Is good. Plus 8 to 9.6, right? Last 125. Like 88. How did you write 125? That is very good. Very nice. What is this? Alpha. This is correct. Okay, I'm not doing the K plus D, you do it yourself, but what is the final answer? 5i. I will double check by doing it. Very good. I think I've already read it. Okay, you just write the formula and I will help you. What is your name? You just write the formula and I will help you. Just write the formula. AB. Okay, we are finding AB, right? Okay, write the formula for me. AB equal to. So it's your call, by the way. It's your call which point you want to start with. If you want to start with A, that is a nice place to start the problem. So write AB equal to AA. Good. Plus. So from here onwards, just copy this formula for me. Okay. So AB equal to AA plus alpha cross. Now just keep replacing them as per. Done? Sure? Positive? Good. Okay, everyone. I will wait 5 more minutes for 10 more minutes for our students. Huh? 5i minus 6.4j. What about, I forgot the name. I forgot his name, if you can. No. Yes. The final answer is 5i minus 6.4j. You got it? Yeah. Okay. You know the formula. Now, instead of AA, 3 meters per second, there is given to me instead of. Go to the next line. Remove this, and we don't need the 2 parts. Go to the next line, equal to instead of AA, right? It's in the I direction. You see? So right here, alpha. Alpha is found as minus 20k. You see the top right one. So right, minus 20k for that. Minus 20k. Okay, minus 20. Cross product, you have B with respect to A. So B is right on the top with respect to A. It has a positive J component to it, and it is at a distance of 100. Yes. So right 100. Positive 0.1 J. 100 over 1000. So positive 0.1 J. Divided by 1000. J. Good. Plus. Now you have omega minus 8. So right, put a bracket across. Cross. I think this position of again 100. Good. Done. Okay. Everyone, thanks for your patience. I appreciate it. So let's finish the problem. So we have AD equal to AA plus omega AB, AD, whatever, doesn't matter actually. Position of D with respect to A. Huh? It's not D. Oh, that's not good. B, 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 B. Thank you. So B, B,
So can we use C instead as well? Or
B. What?
C
Why C?
instead of A?
Oh, yes, absolutely. So we have B, B with respect to A, and then we have alpha B with respect to A. Boom. What is AA? It is 3i. Quickly. Plus omega is minus 8k. Then I have minus 8k. Then B with respect to A is sitting at a positive 0.1 J. Plus alpha I calculated today as minus 20k. Huh? Why what? Why positive J? Because B with respect to A is sitting on top in the positive J direction. And okay, 0.1 J. This is how I defined my coordinate system. So I have AB equal to, why don't you give me the final answer? 3i, 5i, minus 6.4 J. I'm going at sonic speeds right now. Thank you. Okay, let's go back. So 5i minus 6.4 J, it is 5i minus 6.4 J. So I have orange arrow like this. 5i. Oh, come on. It's not even visible. So let me use a purple color. 5i is, okay, it's not visible. Okay. This is, hang on, 5i. Okay, 1 minute. 5i. Whatever this is, let's say. And then I have minus, what was the value? Minus 3J? Minus 6.4J. Thank you. Okay, so it will be, I'm taking a little more than I should on this. Hang on, 5i and minus 6.4J. And I am getting this yellow arrow. This is the direction of the acceleration. 5i meter per second square. And this is 6.4 J, negative 6.4 J. So this is meter per second square. Okay, so we have nice and beautiful. Okay, this is okay, so that's it. Okay, let's finish this topic today, 654-321, so we can start something new. So let me just write the final answers. I have V D equal to 1.2i from my last class plus 1.2j. I'm just finishing it. V A is, what was in the problem? 1.2, correct? Meter per second. Okay, and what was V C, it was 0. Can you please double check? And then what about VB was? How did you figure? It was given in the last class, right? 2. Okay. Okay, thank you. So now I will write here to finish our today's topic. I have this big fellow, which is like this, and I have another fellow like this, correct? And both the chunks are nice and beautiful, going like this. So this plus, hang in there with me, please. This plus, I have another of this chunk. I wish we can have a copy paste, by the way. Okay. Okay, I think it's clear to you. Oh, come on. On your board, you can. Okay. Okay, whatever. Then I have this equal to another of this very quickly. And then very quickly. Okay, done. I have ended up changing the shape, unfortunately. Okay. So now we will finish by saying this was my B, this was my D, this was my A, this was my C. This one I will say pure translation. This one I will say is my pure rotation. This one I will say is my complete motion. You complete the picture quickly. Complete picture. This is not easy, by the way. Okay. So this is my A. Please make sure that the 3 circles are the same. So I just made a horrible diagram. Okay, so
For we didn't write the value.
really?
Yeah, we didn't write the J, K, I.
VB is 2I. Sorry. Yes, thank you. Okay, thank you for pointing out. Oh, good. So done, finished. Then I have, this is my, again, B, then this is my D, and this is the C. This is again D, this is B, this is C. Okay, done. So tell me what is happening here in pure translation. 2 meters per second was the center of mass, right? Right, 2 meters per second. What about the point B? That's nice observation. Good. What about point D? Very nice. What about point C?
Also D, the velocity also goes towards.
Yeah, I know. I'm making it a little confusing for all of you. The whole chunk is going towards right. So point C is also actually in pure translation, the whole object, like, come on, this whole object is going. The whole object is going towards right. Okay, what about pure rotation? So now I will make VB equal to 2I. So there was another 0.8 to it. Boom. Let me use a pink color here. 0.8. Life is beautiful. 0.8 meter per second. This is my 1.2 meter per second. What about VA? 0. Okay, what about VC?
This is the opposite direction.
That's
0.8.
such a good answer. Boom. Boom. What about VD? 1.2I plus 1.2J. Again, one of the students answered us. Thank you. Very nice. Boom. 1.2J. 1.2 meter per second. What about, did I miss anything or not? Yes, no, no. What about complete motion? You just add them. So this is again the same. The center of mass is going towards right. Life is beautiful. VC 0. VD, that is at a 45-degree angle. Last time all of you were telling me. Looks like a 45. No, yes. We are hitting 1225. And VB is 2. Big vector. Big vector. Big vector. 2y. Done. Is it clear? Pure transrotation.
The point A is found velocity of V as 2I. How is it located?
No, no. This is 2.
Oh,
The complete picture of translation plus rotation. Only translation component was 1.2. Pure rotation component is 0.8. The whole piece has 2. Huh? I will answer. No, I will answer. I understood your question, Hussain. Your question is how did we know the I will answer. Let me answer his question. That is a good question. His question is, how did you figure that this rotation component is 0.8? This is how. VB equal to VA plus omega cross position of B with respect to A. You see this chunk that comes from the rotation. So omega is minus 8K. Position of B with respect to A is 100 millimeter, 0.1, 8 multiplied by 0.1, 0.8. The rotation chunk is 0.8. The translation chunk is, so this is your,
basically the equation is made up of translation and rotation.
good, yes.
Rotation translation. So that's how we do it.
Exactly. The whole complete picture has a translation component. Okay, what about Egechan, Muhammad Hashir, Faraz, Uzay? Everything is fine? Do I give you a take-home task? Excuse me. Do you want me to give you? Okay. Quickly, this is your take-home task. Of course, I will be doing it in class as well. Excuse me again, sorry. Okay, oh, come on, time is ending. So this is again, imagine it like this. You have a rack with teeth with a pinion. So one rack on top, one rack in the bottom, and you are doing like this. You know, one hand like this. So it will be a rack on top a rack in the bottom. You have this as your point A. You have this as your point B. Let's go in sonic speed. This is your D. This is your 2 feet per second square. The rack, this is 6 feet per second. The rack, this is 2 feet per second. The rack, bottom rack, this is 3 feet per second square. The acceleration of the bottom rack. Got it? You have to tell me if the radius is 0.25 feet, 0.25 feet, and if this point is my nice and beautiful point D, and this point is nice and beautiful point C, there is no slippage. That being said, I'm not saying for the no slip condition where you use no slippage means that the point C will have the same velocity as -2 feet per second, and point D will have the velocity of 6 feet per second. There is no slippage. The rack and the gear, they are not slipping. Huh? Okay. Okay. Find, give me VB, give me AB. Done. And when you are doing this problem, because of course I don't want to make my life complicated, I am also giving you a coordinate frame of reference, so at least all of us are on the same page. X, Y. No need to even write small x and y. But anyways. By the way, as you are leaving the classroom, can anyone even predict what is the omega? Give me the answer just by observation, the omega. 9. No. Omega? Omega is 16, I think.
So we have to multiply.
4/0.25.
6 feet per second towards right, 2 feet per second towards left, 6 minus 2, 4, 4 by point. So of course, in an exam setting, you are not going to do this. You have to give me the complete formula step by step, and then give me the omegas, the alphas and everything. So you will say VB equal to, let's say, VD plus something something, or you can actually first find the, in fact, one more thing, why don't you also give me VA and AA? And please make sure this is solid object. So I will color this whole thing for you. Bye-bye. Even if it's not solid, that's fine. Why not, please? Thank you.